Last time we looked at how to determine what happened with the ends of the polynomial. Did they both go up, both go down, go opposite directions, whatever? And I told you that we couldn't tell from that information what happened between the ends, how this polynomial is going to behave. So we're going to look at that here. We're looking at the zeros and the multiplicity of the zeros. Now, a zero of a function is what number you put into the function to get a zero out. Now that'll give you a point, right? Like if you put a 3 in, get a 0 out, you'll have the point 3 comma 0, which is on the x-axis. So zeros also are called x-intercepts. And they're really easy to identify if we have the factored form of the polynomial. Here, I know that if I put the number negative 3 in for x, that this will be 0, and anything times 0 is 0. So negative 3 is one of the zeros of this function, negative 3. And positive 1 would make this factor equal to 0. So 1 is another 0 of this function. So that tells me I'm going to have x-intercepts for my graph at negative 3 and 1. But I need to know the multiplicity of the function, meaning how many times is this a 0? Well, this factor that gave us this 0 has an exponent of 1. So that 0 has a multiplicity of 1. This one here, right, if we were to write this out, it would be x plus 3 times x plus 3. So it appears twice because of the squared. So the multiplicity is 2. And we'll look at in just a little bit what the multiplicity tells us about the behavior of the function at that x-intercept. For now, we're just worried about what is the 0, what is the multiplicity. So here, this factor gives me a 0 of negative 4, because if x was negative 4, this would be a 0. Negative 4, with a multiplicity of, if there's no exponent there, we understand it to be 1. Here, positive 1 is the 0, with a multiplicity of 2. And here, some people get confused. They think that should be 1, but it's 0, right? If I were to put 0 in here for x, 0 cubed is 0 times anything will also be 0. So we have an x-intercept at 0 with a multiplicity of 3. Okay, real easy. If you know what you're doing, there's no work involved. You're just looking at numbers. Now, what if our polynomial is not factored? Well, then we have to factor it. Here, x squared is a factor of all 3 of these terms. So we can pull out x squared, and that'll leave us with x squared minus 3x minus 10. And then you remember from a previous course, you may or may not remember, but you're going to need to remember because we need to be able to do this. We need to factor this into 2 binomials. These guys need to multiply to be x squared, so x and x. And these guys need to multiply to be negative 10 and add to be negative 3. So that's going to be negative 5 and positive 2. Right, so now I've got my zeros. My zeros are 0 with a multiplicity of 2, 5 with a multiplicity of 1, and negative 2 with a multiplicity of 1. Okay, so I know where my graph is going to hit the x-axis, and we will know a little something about how it's going to behave based on the multiplicities. All right, one more. And this, I'm doing these examples because they are going to show up in my math lab. Not so much on my tests. Here, we factor this. We need x squared and x squared to give us that x fourth. And the only options for these numbers are 1 and 3, because that's the only factors of 3. And they've both got to be negative. And that would give us our 4x squared in the middle. And then this is really kind of irritating. This one would factor to x plus root 3 times x minus root 3. And this one factors to x plus 1 times x minus 1. Right, remember difference of squares. When you multiply x plus something times x minus something, you get x squared minus that thing squared. All right, so I've got 4 zeros. I've got square root of 3, negative square root of 3, 1, and negative 1. And there's no exponents here, right? So they're all 1. They're all multiplicity of 1. I'm sorry, that's really ugly, but that is the negative square root of 3. That's positive square root of 3. Now I said that these multiplicities would tell us something about how the function interacts with the x-axis, how it's going to behave at that x-intercept. So let's take a look at that. If your 0 has a multiplicity of 1, then your graph of your polynomial is going to go straight through the x-axis at that intercept. If the multiplicity is even, if it's 2 or 4 or 6, we're never going to see anything bigger than 3, I don't think. So just think if it's 2 or maybe 4, it'll bounce off. And if the multiplicity is odd, like 3 or 5 or whatever, again, we're not going to see anything bigger than 4. So just think if the multiplicity is 3, and so 2 or 4 there are really the only options, and 3 is really the only option there, then your graph is going to go through the x-axis at that intercept, but it's going to do it with a little bit of a wiggle. Okay, let's look at how that works here. This graph, I know if I multiplied this all out, I'd have x times x squared times x cubed, which is x to the 6th, and the first term would be positive. So I know my end behavior. Both ends are going to go up. And I know it's going to cross the x-axis at positive 1, positive 4, and positive 7. Okay, so I've drawn the 1, 4, 7 on the x-axis there. And I know that at 1, it's going to go straight through because it's got a multiplicity of 1, so it's going to go straight through. So my graph's going to come down from positive infinity there, and it's going to go straight through the x-axis at 1. 4, our 0 of 4 has a multiplicity of 2, which means the graph's going to bounce off the axis there. So it's going to come up from here and bounce off and turn around. We call that a turning point in polynomials. We call this a turning point also. And it bounces off. And then at 7, I know that's an odd multiplicity. Odd multiplicity says it's going to go through with a wiggle. So it's going to turn around again, and it's going to go up to the axis, curve a little bit, go through, and then curve a little bit again, and then continue on up to infinity. Now, this is not a super realistic looking graph here, but we're not after realism when we graph in this class. We're after, do you understand the behavior of the function? So what I'm going to be looking for is, ends go in the right direction? Yes. Crossing at the right places? Yes. Crossing correctly, going straight through, bouncing off, and going through with a wiggle? Yes. And does it look like a roller coaster instead of having sharp corners and gaps and stuff? Yes. That would be, for my purposes, a perfect graph of this polynomial function. See you next time.